My dear students, today we are going to start a new lesson, that is chapter number 8, Introduction to Trigonometry. What is trigonometry? Trigonometry is the study of relationship between the sides and angles of a triangle. A triangle has three sides and three angles. So trigonometry deals with the relationship between these three sides and three angles. Trigonometry is the study of relationship between the sides and angles of a triangle. But in class 10, we restrict this to the ratio of the sides of a right-angled triangle with respect to the acute angles. In figure, we have a right-angled triangle at B. That is, angle B is equal to 90 degree. Therefore, angle A and angle C are definitely acute angles. I represent the measure of angle C by a Greek letter theta. This is a Greek letter theta which is used to represent the measurement of angle C, which is an acute angle, such as 40 degree, 50 degree, 60 degree, like that. Now, with respect to the position of the acute angle theta, the three sides of the triangle ABC can be named as, first one, perpendicular. Perpendicular is the side opposite of angle theta. Second, base. It is the side which is adjacent to angle theta. And hypotenuse, that is always fixed, the side opposite to right angle. Here it is AC. So, for this right angled triangle, if angle C is considered, which is an acute angle, with respect to the position of angle C, represented by theta, perpendicular is AB, base is BC, and hypotenuse is AC. But if you consider angle A, which is an acute angle, the perpendicular will be BC, base will be AB, and hypotenuse will be AC. Hypotenuse will never change, only the base and perpendicular may interchange. That is with respect to the position of the acute angle. Now, what is trigonometric ratios? The trigonometric ratios are the ratios of two sides of a right-angled triangle at a time with respect to the position of an acute angle. I repeat, the trigonometric ratios are the ratios of two sides at a time with respect to the position of an acute angle. There are 6 trigonometric ratios. They are named as sine ratio, cosine ratio, tangent ratio, cosecant ratio, secant ratio, and cotangent ratio. Sine ratio is defined as perpendicular to hypotenuse. Cosine ratio is base to hypotenuse, and the tangent ratio is perpendicular to base. And cosecant ratio is hypotenuse to perpendicular, secant ratio is hypotenuse to base, and cotangent ratio is base to perpendicular. You can see that last 3 ratios are the reciprocals of the first 3 ratios. In short, these ratios are called as sine, cos, tan, cosec, sec, and cot. Here we have a right angle triangle in which angle C is considered, which is an acute angle, whose measurement is represented by theta. So, with respect to the position of angle theta, the trigonometric ratios can be defined as, in right triangle ABC, sine theta. Sine theta means the sine ratio with respect to the acute angle theta. Sin theta is equal to AB, which is the perpendicular, by AC hypotenuse. Cos theta is equal to base BC by hypotenuse AC. Tan theta is equal to perpendicular AB by base BC. Similarly, cosec theta is hypotenuse AC by perpendicular AB. Sec theta is equal to hypotenuse AC by base BC, and cot theta is equal to base BC by perpendicular AB. These are the basic trigonometric ratios: sine, cos, tan, cosec, sec, and cot. All these ratios are defined with respect to the position of an acute angle of a right angled triangle. Now, if I take angle A, which is also an acute angle, if theta is used to represent the acute angle A, then in right angle triangle ABC, the sine ratio will be, that is sine theta will be equal to perpendicular BC by AC, hypotenuse AC. Cos theta will be base AB by hypotenuse AC, and tan theta will be perpendicular BC by base AB, and cosec theta will be hypotenuse AC by perpendicular BC. Sec theta will be hypotenuse AC by base AB, and cot theta will be base AB by perpendicular BC. So there are three sides for a right angle triangle. They are named as perpendicular, base, and hypotenuse with respect to the position of an acute angle. By taking two sides at a time, the ratios are defined, and these ratios are named as sine, cos, tan, cosec, sec, and cot. Now we start exercise 8.1, which is based on the concept of trigonometric ratios. Question number 1. In triangle ABC, right angle that will be AB equal to 24 cm, BC equal to 7 cm. Find sin A, cos A, and sin C, cos C. We have to find the trigonometric ratios of the right angle triangle with respect to the acute angle A and acute angle C. To find the trigonometric ratios, we always need the hypotenuse. Here for the right angle triangle ABC, the hypotenuse is not given. We will use Pythagoras theorem to find the hypotenuse AC of the right angle triangle ABC. In right triangle ABC, AB is equal to 24 centimeter and BC is equal to 7 centimeter. By Pythagoras theorem. Pythagoras theorem states that for a right angle triangle, h square is equal to b square plus p square. That is, square of the hypotenuse is equal to sum of the squares of the other two sides. Here, hypotenuse AC is equal to, when you use Pythagoras theorem, base and perpendicular means the other two sides of the right angle triangle except hypotenuse AC. So here you can take AB as the base, that is AB square plus P means BC square. That is equal to 24 square plus 7 square, 24 square 576 plus 7 square 49, which is equal to 625. Therefore, AC is equal to root of 625, which is 25 centimeter. So we are getting the length of the hypotenuse AC. So here we have all the three sides of the right angle triangle ABC. Now we will find out the respective trigonometric ratio required. First one, it is sin A. Sin A means the sine ratio with respect to the acute angle A. Sine ratio is defined as perpendicular by hypotenuse. For the acute angle A, perpendicular is the opposite side, that is BC. So, BC by hypotenuse AC. BC is 7 centimeter. So, 7 by hypotenuse AC, that is 25. Since it is a ratio, there is no unit. Similarly, cos A. When you take cos A is defined as base by hypotenuse. For acute angle A, base is AB, hypotenuse AC. AB is 24 by 25. Remember, a trigonometric ratio has no unit. Second, we have to find sin C. When you take sin C, the acute angle to be considered is angle C. With respect to the position of angle C, the base and the perpendicular will change. Here, if we take sine ratio with respect to the acute angle C, the sine ratio is defined as perpendicular by hypotenuse. But here, with respect to the position of acute angle C, perpendicular is AB. So it is equal to AB by hypotenuse AC. AB is equal to 24 by AC 25. Similarly, cos C is defined as base by hypotenuse. Here, with respect to the position of acute angle C, base is BC. So, BC by AC. BC is 7 centimeter. So, 7 by 24. Sorry, 25. Hypotenuse AC is 25. So, this is how we can write the trigonometric ratios with respect to different acute angles. The next question is question number 5. If sec theta is equal to 13 by 12, calculate all other trigonometric ratios. Sec theta is equal to 13 by 12 means it is for a right angle triangle. So let us draw a right angle triangle. In which angle B is 90 degree. One of the two acute angles may be marked as theta. Here we are going to solve this question without using the figure. I have drawn the figure just to understand that the trigonometric ratio is defined for a right angle triangle. Here, given sec theta is equal to 13 by 12. Sec theta is defined as hypotenuse by base. Sec ratio is defined as hypotenuse by base is equal to 13 by 12. Since we have the ratio of hypotenuse and base, therefore let hypotenuse h is equal to 13x and base b is equal to 12x. Because when the ratio of two quantities are given, we take the values with the help of a variable. Here the ratio of hypotenuse and base is equal to 13 by 12. Therefore h is equal to 13x and b is equal to 12x. Now we want to find the perpendicular. To find perpendicular, we will use Pythagoras theorem. By Pythagoras theorem, h square is equal to b square plus b square. Here h is 13x, the whole square is equal to b, 12x the whole square plus b square. 13x the whole square is 169x square is equal to 12x the whole square is 144x square plus p square. So that gives p square is equal to 169x square minus 144x square, which is equal to 25x square. Therefore, perpendicular p is equal to root of 25x square, which is 5x. Here we are given the seek ratio. Seek ratio means hypotenuse by base. So hypotenuse by base is equal to 13 by 12. Since we are given the ratio, we take h is equal to 13x and base is equal to 12x. By using Pythagoras theorem, we can calculate the perpendicular. So, in a right angle triangle, there are three sides. With respect to the position of the acute angle theta, we have a hypotenuse 13x, base 12x, and perpendicular 5x. Now we have to find all other trigonometric ratios. Therefore, sin theta is perpendicular by hypotenuse, perpendicular 5x by hypotenuse 13x. Here x and x will be cancelled, so 5 by 30. The next ratio is cos theta. Cos theta is base by hypotenuse. Here base is 12x by hypotenuse 13x. X will be cancelled. We get 12 by 30. The third ratio is tan theta, that is perpendicular by base. Perpendicular is 5x by base 12x. X and x cancelled, we get 5 by 12. Next ratio is cosec theta, which is hypotenuse by perpendicular. Hypotenuse is 13x by perpendicular is 5x. X will be cancelled, so we get 13 by 5. The next trigonometric ratio is sec theta, which is given, and so we have to find cot theta, which is the last trigonometric ratio, which is defined as base by perpendicular, base 12x by perpendicular 5x. X and x will be cancelled, 12 by 5. Hence, we get all the remaining trigonometric ratios. Here we can notice that cosec theta, sec theta and cot theta are the reciprocals of sin theta, cos theta and tan theta respectively. Now look at question number 8. If 3 cot A is equal to 4, check whether 1 minus tan square A by 1 plus tan square A is equal to cos square A minus sin square A. Here we have to calculate the trigonometric ratios tan A, cos A and sin A. We are given 3 cot A is equal to 4. Given 3 cot A is equal to 4, therefore cot A is equal to 4 by 3. Cot A is equal to 4 by 3, that is, cot ratio is defined as base by perpendicular, so it is equal to 4 by 3. So cot A is equal to 4 by 3 means base by perpendicular is equal to 4 by 3. This is a pure ratio. Therefore, let base B is equal to 4x and perpendicular P is equal to 3x. Now we will use Pythagoras theorem. By Pythagoras theorem, h square is equal to b square plus p square. B is 4x the whole square plus p is 3x the whole square. 4x the whole square is 16x square plus 3x the whole square 9x square. 16x square plus 9x square is 25x square. Therefore, hypotenuse h is equal to root of 25x square, root of 25, 5x square, so is x. So h is equal to 5x. So by using 3 cot A is equal to 4, now we have the perpendicular, base and hypotenuse. Perpendicular is 3x, base is 4x and hypotenuse 5x. Now we can write the required ratios. Now cos A is defined as base by hypotenuse. Here base is 4x by hypotenuse 5x, so 4 by 5. Sin A is defined as perpendicular by hypotenuse. Here perpendicular is 3x by hypotenuse 5x, so it is equal to 3 by 5. And tan A is defined as perpendicular by base. Here perpendicular is 3x by base 4x. 3x by 4x is equal to 3 by 4. So we have all the required ratios. Now 1 minus tan square A by 1 plus tan square A. We have to calculate 1 minus tan square A by 1 plus tan square A. That is equal to 1 minus tan square A means 3 by 4 the whole square divided by 1 plus tan square A is 1 plus 3 by 4 the whole square, which is equal to 1 minus 3 square 9 by 16 whole divided by again 1 plus 9 by 16. Taking the LCM and simplification, 16 into 1 16 minus 9 whole divided by 16 by 16 into 1 16 plus 9 whole divided by 9. That is equal to 16 and here 16 will be cancelled. 16 minus 9, that is 7 by 16 plus 9, that is 25. So by calculating 1 minus tan square A by 1 plus tan square A, we are getting 7 by 25. Now we have to find out what is cos square A minus sin square A. Cos square A minus sin square A. The value of cos A is 4 by 5 the whole square minus value of sin A is 3 by 5 the whole square. 4 by 5 the whole square is 16 by 25 minus 3 by 5 the whole square is 9 by 25. Same denominators. 16 minus 9, that is 7 by 25. That is 1 minus tan square A by 1 plus tan square A is equal to 7 by 25. Also cos square A minus sin square A is equal to 7 by 25. Therefore we can say that 1 minus tan square A by 1 plus tan square A is equal to cos square A minus sin square A. So we have verified that 1 minus tan square A by 1 plus tan square A is equal to cos square A minus sin square A. The next question we are going to do is question number 10. The question is, in triangle PQR right angle at Q, PR plus QR is equal to 25 cm and PQ is equal to 5 cm. Determine sin P, cos P and tan P. So we are given a right angle triangle, right angle at Q with the PQ is equal to 5 cm and PR plus QR is equal to 25 cm. The sum of the hypotenuse and one of the other two sides is 25 cm. So here I am going to assume let QR is equal to x. Since the sum of these two sides is 25 and QR is x, then PR can be 25 minus x. So now we have the three sides of the right angle triangle PQR. By using Pythagoras theorem, we can find the value of x, hence the sides QR and PR. In right triangle PQR, right angle at Q, PQ is equal to 5 cm and PR plus QR is equal to 25 centimeter. Let QR is equal to X centimeter. Therefore, PR is equal to 25 minus X centimeter. By Pythagoras theorem, hypotenuse PR square is equal to PQ square plus QR square. By Pythagoras theorem, the square of the hypotenuse is equal to sum of the squares of the other two sides. Here PR is 25 minus X the whole square is equal to PQ square 5 square plus QR square X square. This 25 minus X the whole square is to be expanded by A minus B the whole square, and you will get 25 square 625 plus X square minus 2 into 25 50X is equal to 5 square 25 plus X square. Now you can cancel X square from both the sides, and we have 625 minus 50X is equal to 25 minus 50X to RHS, 25 to LHS. 625 minus 25 is equal to 50X. That gives 50X is equal to 600. Therefore, X is equal to 600 by 50, which is 12. So, we are getting the value of X. Therefore, side QR is equal to X, which is 12 centimeter. Side PR is equal to 25 minus X, 25 minus 12, that is 13 centimeter. So we have now all the three sides of right angle triangle PQR. Now we can write sine P. Therefore, sine P, sine ratio is defined as perpendicular by hypotenuse. With respect to the position of angle P, perpendicular is QR by hypotenuse PR. QR is 12 centimeter by PR is 30. Now cos P. Cos P is defined as base by hypotenuse. With respect to the position of acute angle P, base is PQ by hypotenuse PR. PQ is 5 centimeter by PR is 30. So 5 by 30. And finally, tan P is defined as perpendicular by base. Here, with respect to the position of angle P, perpendicular is QR and base is PQ. QR is 12 by PQ is 5. So 12 by 5. So hereby we are getting the three required ratios, sin P, cos P and tan P. I hope you understood the basic concepts of trigonometric ratios, and hereby I complete the first exercise. We will do the next exercise in the next class. Till then, take care. Goodbye.